All right, here we are with 8-1, day 2. Sticking with the law of sines, but we're going to look at one particular case. It's a little bit different than the other two. It's called side-side angle. So this would be like we've got a side, right? And then we've got another angle that's not in between. Okay, if the angle were in between, we'd call it side, angle side. Different case. It'll actually come up later on. Okay, we'll see that probably next week. Actually, different case. Side angle. Okay. So if you're given this, there possibly could be two options, right? We could go ahead and solve it like law of sines. If that's the case, then we're going to get the acute case. So like we're searching first for an angle, right? So that's also where this is a little bit different, is you're going to see when it's set up, you have to do an inverse first because you're going to be finding an angle. We're always going to solve for the acute answer to that first, okay? There may be a second option, right? The obtuse option, which you would get from subtracting our answer from 180, right? Because remember, if we're dealing with sine, right, this takes us back to when we were solving back in chapter 7. To get our second case, right, we would take our first answer and subtract it from 180. This was only for sine, like cosine and tangent had different rules. But this is the law of sines. So we're specifically dealing with the sine function. Okay, so we have to check. It's possible there's just the one case. There's this scenario that shows up where we have to see that, okay, this missing angle, it could be a scenario where it's acute, and then there could be a scenario where it's obtuse. We'd have to check both possibilities. Now, each one of these I continue to label the case. Right, here's side angle. Okay. And you'll see with this case, you have to solve for sine of A first. You'll see there's no other option for how to set it up. And then I could set this equal to sine of 60 over 4. Okay. The other cases were a little bit different, as I typically found in day 1 that we were finding a side length first. Okay, not the case here. (14) times the sine of 60 over 4. That right side is going to be a trig value, which we said round that to 4 decimal places. We go ahead and do our inverse. And the calculator gets a little grumpy with us, says, nope, not going to do that. Which we've seen this scenario before. We're taking an inverse sine of a number that's bigger than 1. There are no solutions. Okay, so this actually is a case that would yield 0 solutions. So yeah, the diagram isn't to scale, but the dimensions that it gave us, this is basically saying it's not possible to construct a triangle with those dimensions. Okay? Not possible. There is no solution to what you're looking for there. All right, again, we're going to be side angle. It should be labeled as degrees. I'll label this one ahead of time. This is going to yield 1 solution, but you're going to see I have to check for 2. Okay? And here's kind of how it goes. I look at this whole diagram and say, all right, sine of B is where I have to start. That's over 12. And then I got to use sine of 42 is over 22. Cross multiply and divide. Really just have to multiply both sides by 12. 12 sine of 42 over 22. Which gives me that 0.3650. Do an inverse. And angle B is 21.4 degrees. Okay? So here is where I'm going to split this up now. And here's the acute case. Okay? There's another possibility in terms of its sine value that angle B could be 180 minus 21.4. And in terms of its sine value, we would get the same thing. Okay? So you have 150, let's see here, 158.6. Okay? So here's basically what I'm left with. This missing angle, right? In this side-side angle case, based off the formula, it could be 21.4 mathematically, right? 158.6, it could also be as well. And again, my diagram's not to scale, so it's kind of left as a mystery. Is this is this missing angle supposed to be acute or obtuse? I'm just going to proceed either way, okay? Case number one, I'm going to say, all right, B is 21.4, okay? I need to get C. Okay, a missing angle would be 116.6. And then side length C. over, let's see, opposite sine of 42. And then C is 22. Sine of 116.6 over the sine of 42. Which comes out to be 29.4. Okay, so after I figured out that B was 21.4, I had to go get angle C and side C. Okay, I had to go back and get those two. Okay, which is right here and right here. This is if B is 21.4, okay? So now I look at my obtuse case. Like that scenario is possible. That could be the solution to all the missing dimensions of our triangle here. So now I do the exact same thing, right? To see, is the second case possible? Angle C, right, would have to be 180 minus 158.6 minus 42 which would give us negative 20.6. I can stop right there and tell you that this case number 2, right, which would involve angle B being an obtuse angle at 158.6 is not possible. Okay, so this is a one solution. Case number 1, where my first missing angle, B, being 21.4, that's the only possible case as to way this triangle could be constructed. Okay, the second possibility mathematically can't work. Okay, so it was kind of misleading with the formula that it told me, hey, based off the numbers, that missing angle for B maybe could be obtuse. It could be 158.6, but then I kind of proceeded with that case and saw, no, that's not happening. All right, once again, notice side-side angle. The math here is going to be the same, except this is going to be the first case where you're going to see both solutions will actually be possible. Okay? Both solutions will actually be possible. All right, sine of B over 5, right? You're going to see the whole process is going to be exactly the same, right? I have to start and find angle B. Sine of 58 over 4.5. This would be 5 times the sine of 58 over 4.5. .9423. Angle B is 70.4 degrees. Okay. Now I'm confident, like on the other case, that case number 1, where B is 70.4, is going to work. That one typically always works out. Here's the other possibility we have to consider. (180 minus 70.4) is that angle B 109.6. Okay, those are the two solutions. Okay. Now that's for this angle up here. All that's left here is I got to find angle C and side C. And I basically do the same math, but the first case considers, all right, what if angle B is acute and it's 70.4? Okay, we'll just go and we do our thing. Okay. There's angle C. Once I have that, I can do side C, putting it over sine of 51.6. And then we can use 4.5. Throw that right side into a calculator, and we'd see that side C is 4.2. No unit, so we would just call it 4.2. Okay? So again, those are the two things I'm after here. Angle C, side C. And we saw this in the previous example. Case number 1, which again will give you an answer for that first missing angle that's less than 90 degrees. It works. Okay, that's a possible solution. Or is angle B supposed to be 109.6? Well, we do the exact same thing. basically all that changes is in this calculation. Everywhere you see $70.4, it gets replaced with 109.6. And it has a little bit of a domino effect, right? So this is where we called off the last one because we saw that the next angle wasn't possible. We got negative 20.6. Here that doesn't happen. If B was 109.6, C would be 12.4. That conceivably could work. Now let's go get side C. In this case, I found that angle C would be 12.4. Four and a half and 58 degrees don't change at all because those were given. So I knew those measurements before I started. So there's your second case, right? If B was 109.6, angle C would be 12.4, side C would be 1.1. Okay, there we'd have to like visualize what our problem was. There we'd need if you had a diagram or a representation to scale, then you could observe angle B and be like, which scenario are we talking about here, right? Because all we were given is say, hey, angle A is 58, side A is 4.5, and then side B is 5, right? It's all we had to get going. A diagram of the situation to scale would give you a lot of insight, right? But just off the numbers, in this case, the law of sines, it doesn't tell you nothing. It can narrow it down to two possible triangles based on the numbers we were given. But the formula itself, without actually seeing the situation, can't tell us exactly which one it is, the 70.4 or the 109.6. All right. This is a totally different thing. So it's kind of hard in this unit as to where to put this. It's a pretty easy little formula to use, but you got to be okay that it does some different stuff. Primarily, it gets us area. Okay, it doesn't give us a side length. It doesn't give us an angle. And if you're looking off of cases, right, this works for what we call the side angle side case. Okay, which comes up if you have, there's a bunch of different scenarios. Like look at the first, right? If you had A and then B and then angle C in between, right? Two sides in the included angle. That was different from what we were working on. Like we had two sides in an angle, but the angle was not in between the two sides, okay? If you have that, we can find the area of that triangle pretty easily. Okay, I think for the most part, the only area formula you've seen for a triangle would be 1/2 base times height. Essentially, these formulas allow you to get the area without knowing the height, right? Two sides and the angle in between is actually good enough to do it. So based on the diagram, here's what we have. 80 degrees. This side is 18, this side is 24. So we'd have 1/2 times 24 times 18 times the sine of 80. Round it to the nearest tenth. It did give us the units of yards, and this is an area, so we'll say yards squared, okay? It's a pretty doable little formula to use. It's not too bad, okay? It's really not too bad. Yeah, works for the side angle side case. Didn't need the height to get that area. My only concern here is just that we tagged it on the end of this lesson, but this is a different thing, right? This is not the law of sines. Like it involves the sine function, but it's an alternative formula to get area. It doesn't get angles or side lengths. So be sure to keep it kind of separated from the other stuff we did today.